Welcome back to our set of training videos on the Leica SP5 confocal microscope. We're coming to you from the microscopy suite in the biology department at California State University, Northridge. Once again, we would like to thank the Keck Foundation for their generous support in supplying the funds which produce these videos. Remember that in our research using the confocal microscope, we're working with molecules called fluorophores. And these are specific dyes which allow us to bind them to the molecules or areas of the cell that we're interested in investigating using the immunohistochemistry complex. Now, fluorophores are special dyes that emit light when they're excited by light. And so today you're going to see how we're going to use one laser line of light to excite a fluorophore and cause it to emit light in a known area of the spectrum that we're interested in seeing. That way we can watch live cellular processes in process as these molecules move around the living cell. Another important thing to recognize is that fluorophores can be excited with laser light, however they tend to photobleach. What is photobleaching? Photobleaching is the process whereby a dye fails to emit light after being excited a certain number of times. Usually about 1 million excitations is enough to give us emission light from a fluorophore. But if we use too much illumination or we have the laser on for too long, we will photobleach, or we will essentially dry out or use up our fluorophore so that it no longer emits light. So it's important to realize that you have to work quickly in order not to photobleach your fluorophores. Previously, we used a power-up sequence that included activating all of the buttons on the front panel except for the laser key. So we have initiated power on these 3 buttons, and now we're going to use the laser, so we'll turn on the laser key, and this applies basic power to our laser bench. As before, we want to turn on the epi-fluorescence illuminator that's a part of the microscope, and here you can see the power button has already been pressed and the light is on. The second thing we want to do is make notice of our transmitted light illuminator on the microscope. Remember, when we power up the microscope, this illuminator goes to maximum voltage. So it's always a good idea to come over to the left side of the microscope and turn down the transmitted light illuminator as you were shown previously. This saves life on the bulb. Now that the microscope has been powered up fully, including the laser bank, our attention turns to the Windows menu and logging into the system. And so to do that, we will work with this screen right here. And you'll see that there are 2 activated buttons on the screen. One is for administrator access and the other is for TCS user. You will be logging in using the TCS user login. And so you click on this active button and it asks you for a password. The password is then entered. And the system begins to boot. Now, the first thing you see on the screen is a list of icons on the left of the screen which are related to the microscope and the computer. Several of these you will use from time to time, but some of them you will not use. And it's very important that you understand which ones you can use and which ones you can't. Obviously, the My Computer icon will allow you to look at the disk drives, and we'll do that in a second. There's also a DVD burning tutorial that allows you to burn DVDs for your data storage. There's QuickTime Player available to you because you will be making videos, live videos of time-lapse, or what we call Z-stacks, which are a series of images taken through a grouping of cells. And so you may want to make videos and watch those on this computer or others. At the very bottom of the list of icons is a very useful introduction to confocal microscopy, which you may want to refer to from time to time. This is always available to you on the screen. This icon just above the bottom is one that I do not want you to interact with. This has to do with setting up the computer and the microscope parameters, and this should only be handled by an administrator. At the center of the screen, you see the LASAF icon, which boots up the Leica confocal microscope software. I've also put an image on here for use in this tutorial. We'll show you what the point of this image is in a second. Let's begin by clicking on the My Computer icon. And if you're a PC DOS user, you're familiar with this screen. This shows you the drives that are on the system. There's a C drive which contains the operating system. And most of the files that are prepared during the use of your experiment will be stored on this drive. It is also the drive where all the scratch memory is written until you decide to save files into your user folder. It is important to save your files from time to time because this C drive will quickly fill up with the random access memory that's being written to the drive before it's finally saved. And so you can actually crash the operating system by not saving your files from time to time. Your files will be saved on the D drive, which is a very large drive, and it contains all the folders for different users. Here you see the users folder. We'll double click on that. And now you can see a list of the users that come and use the confocal microscope. And so when you come in to work with the instrument, you'll have your own folder and all of your files will be stored in that folder. So please remember to store your files from time to time as you're working with the instrument so that you won't fill up the C drive and crash the system. Finally, you'll see that there is a DVD read-write drive. This is the only way for you to store information, data, pictures, experiments from this computer. You will not be able to use a thumb drive on this instrument. We have no virus software, and so if you bring a thumb drive, don't plan to use it. We have plenty of DVDs available for you to burn all of your experiments, pictures, data, films, etc. Once again, the icons on the left side of the screen are available to you as follows: My Computer, the Creator Basic to burn your DVDs, of course the Recycle Bin, QuickTime Player to show your videos and movies, and this bottom document, which is a reference document for laser scanning confocal microscopy. Please do not use the Leica hardware configuration icon. Now we will boot up the Leica LAS AF software by double-clicking on this icon on the center of the screen. Please leave this icon on the center of the screen so other users can find it. The system will begin a series of initializations whereby the computer is talking to different components of the microscope. It's testing to make sure that all the galvanometer mirrors in the scan head are working, that the software is talking to the XY stage, the Z axis, the illumination, and the different functions within the microscope. It brings up an OK to continue button, so you click on that, and the system will continue to initialize, and you can see that here on this real-time readout of what the system is doing. As you can see, the system is now prompting me to initialize the stage. I would click on this yes button, but before I do, I have to make sure that my stage is free and clear for the initialization. You have to make sure that the condenser is free and clear of any portion of the mechanical stage. If you have a multi-well plate on here or some other structure, remove that at this time and make sure that there's a clear space between the condenser and the stage. Also ensure that the nose piece is dialed down to an empty spot or the 10x objective. Do not turn the nose piece to any other position. It is also very important to remember not to touch the stage with your hand or anything while the stage is initializing. Please allow the stage to initialize completely before you touch it. The LAS AF software is now fully initialized and ready for use. Let's focus on the left side of this screen for a moment. You'll see first of all that Z-Stack is the default setting that comes up when the software is initialized. We won't be using Z-Stacks right away, so let's minimize this tab by clicking on this arrow. The one that we are interested in initializing, however, is the XY Acquisition tab. We'll explain more about this in a second. You'll be working with this tab and also the XYZ tab up here, but I want to point out these first two major tabs which allow you to choose between experiment and acquisition. When you're running the microscope and doing an experiment, you'll be mostly working under the Acquisition tab. However, from time to time, you'll want to look at your experiment. And so you click on the Experiment tab, and a whole list of the pictures, Z-stacks, and other information that the system has recorded will be listed here. However, please remember, everything listed here is only in random access memory, or RAM, until you select to save all, and you can do that down here at the bottom. We'll show you more about that in a second. So let's go back to the Acquisition tab, and this allows us to control parameters of the microscope. Above the Experiment and Acquisition tabs are 4 other tabs. Configure, which is one we'll come back to in a second. Acquire, and that's the tab that we use when we're actually running experiments and gathering data. Process, this allows us to take advantage of a whole host of functions that allow us to process our images. And finally, the Quantify tab, which allows you to export files for reporting, graphs, and such. And so right now, we will focus on the Acquire tab and the Configuration tab. Once the software is completely initialized, you go to the Configuration tab and you turn on the lasers. You'll see here a list of functions available to you for the microscope. These are very powerful. Some of these I want you to use, other of these I need you to stay away from. Do not activate the microscope icon under the Configuration tab, nor do I want you to activate the objective icon. You'll focus on the laser, and when you click on that icon, you see another screen come up that allows you to power up the available lasers. Let's go ahead and apply power to each one of the lasers. You might hear initial fans start up, which cool the lasers because they generate a lot of heat. Notice that the argon laser has a slider bar for application of power. We need to bring the power for the argon laser up to about 20%. And so you bring it to 20%, don't go any further, and leave it at that point. I have it at 18 just to conserve power. The rule of thumb is to use as little power on the lasers as possible, as this will prevent photo bleaching, which you will see in due course. In addition to the Laser tab, there is a Beam Path tab. Again, please do not interact with the Beam Path icon, nor do I want you to interact with the Stage icon. However, the Dyes icon is very important. A lot of information about the fluorophores or the dyes that we'll be working with. So if you click on that icon, a new screen comes up that shows you all of the different dyes that are available. We can add to this list of dyes also. So if there's a fluorophore that you're interested in working with, we can add it to this list. But notice that I've selected DAPI, and in this column I see the excitation wavelengths and the emission wavelengths for this particular fluorophore. To the right, I also have a graph which shows me the excitation curve. This is the amount of light that's required to excite this fluorophore at a given wavelength, and you can see the peak is right here. And then we have an emission curve, and this is the amount of light that's generated by the fluorophore after it's excited. Again, it has a peak. Now we can find that exact peak on this listing of numbers, and so if we scroll up and down here, you'll see 100% excitation takes place at a wavelength of 358. So that is the peak excitation wavelength that we want to use to excite DAPI. What about the emission? If we click on emission, again we can scroll down until we see 100%. We click on that, and now you see that at 461 nanometers we have full emission from our fluorophore. So that we know the excitation wavelengths and the emission wavelengths for this particular fluorophore. So this is a very useful reference tool to be able to study the different dyes that you might be interested in and what their excitation and emission wavelengths might be. Another useful icon on this configuration screen is the control panel icon. If you click on that, you see a rectangle that comes up with a set of circles in it. These circles correspond to the control panel, which is on the desktop. And you can see that these are set up for different functions. These are fully programmable. And so if you do not like the functions that are in here, you can set up the functions that you'd like to control with the manual control panel, which is on the desktop. Additionally, you can set the sensitivity for these dials. If you find that the dials are too sensitive, you can lower the sensitivity, so it'll take you more turns of the dial to activate the function that you're currently using. Therefore, by using the control panel icon in the software, I can program each one of these functions to a different function if I don't like the way they're set up, and I can reprogram the sensitivity of each one of these knobs.